GraphQL subscriptions when the subscriptions keyword was just in the specification, but nobody really know what GraphQL subscriptions are. So yeah, maybe you want to talk more to relate afterwards how this first implementation looked like, but it was mostly based on service and events, and the current implementations are rather aiming to websites. So yeah, there are two proposals currently for the GraphQL subscriptions. One is created by Optonaut, and then there is a RFC process currently ongoing to bring official GraphQL subscriptions officially into the GraphQL specification. But the way how you can use GraphQL subscriptions today is through Apollo's proposal. Right. So what this protocol proposal basically entails is, or what it specifies is that it's based on WebSockets. So the client and the server are connected via WebSockets. The proposal they're proposing is not similar to Relay or any other technology bound to certain clients or certain servers, but it can be used from within any server implementation and with any client. In general, what you have to keep in mind is that this is a first GraphQL subscription proposal, so it's still early. There are a couple of edge cases which are still to be explored, but it's something you can already use today, and in fact, a lot of companies already use it. So what this how this protocol proposal looks like is that it has certain messages it sends over WebSocket connection. So when the client interacts with the server, the client can either send a init message. So this is how the server, hey, I want a connection, a subscription with you, and this is what and the subscription start, it sends the query, the subscription end, it sends anti-subscription, and the server in these cases can respond for the init with the init success or init failure. For the subscription start, which sends the subscription query, the server can also say that true data failed. And the important bit of this is basically where the data is transferred. This is sent via a subscription data message. And to keep the entire connection open all the time, even if there is no data flowing, the server periodically sends a keep-alive packet to the client. So if you're opening a WebSocket connection via a browser and you use a Chrome web tools, you can basically look at how this inserts. So you just establish a WebSocket connection, and here you see how these messages are being sent. So at the beginning, you see the initiated, then you see the success. You send the GraphQL subscription query, then the subscription success. The client and the server sends the first keep-alive packet, and then the first data already comes in. And let's say if this demo would be ending the subscription afterwards. Right. Does this message model make sense to everybody? Okay. Then you can already look how this looks like on the client side. So when Apollo proposed their GraphQL subscription architecture, they also said proposed a way how it could look like in a complete JavaScript stack. So first we're going to look at the client side. So they've created this package called subscriptions/WebSocket, which in theory can be used across any kind of GraphQL client. So you can use it for the Apollo client, in Relay, but also use it in any kind of JavaScript client. So what this tool does is that it works across all technologies, and is also the foundation can be the foundation for JavaScript-based subscription servers. So this is responsible for establishing the WebSocket connection. So who of you has already used So, um, so I just want to show you how this is being used with Apollo. So this is very minimal code base of how you can use that as subscriptions. So let's walk through. The first line, we're importing the subscription client and a helper method from the subscription transport web service package. And in the second line, we just import a view of the Lambda code client. Here, I think it's familiar to everybody. We just instantiating a network interface for that code client. And here we're basically using the same thing, but for the website connection. So what's important to note is that you have additionally to your HTTP endpoint for your GraphQL server, you also need a WebSocket endpoint for your GraphQL WebSocket server. Right. So you have these two network interfaces. Basically, you combine it into one, and then essentially your Apollo client with this combined network interface. Does it make sense? Alright. And now imagine somewhere in your React component, somewhere in your Angular view, or but somewhere in your JavaScript application, you want to have all set up already, and somewhere in the application, you now want to subscribe to a certain message. So this is how this will look like. Then you say Apollo client subscribe to more. Here you have your GraphQL subscription page. And this is basically where the magic happens. So you have your update query callback, and this is being called every time a new message comes in. And here you can basically do whatever you want to do with it, and you want to update your component state, or you want to put it into readout somehow. This is basically up to you. Right, and that's basically all you need to know about subscriptions. There are a couple of use cases which are maybe not as clear here. So one of it is for normal HTTP-based request for request response. It's pretty simple how you application, for example, you use HTTP headers, but how do you do that with GraphQL subscriptions? So the way it works is that you have a connection errors object you can put when you essentially your subscription client. And here you can basically put any kind of parameters. You can put it on like HTTP headers, but these are properties for your website connection. And here you can, for example, if the server allows you to send an authorization per method, this is the place where you can put it. Alright, so before we dive into demo, I already want to give you a quick overview of how this looks like. So this is our component structure. We have an app component. Inside this app component there is a road type component which contains a map. So this requirement emoji basically signifies that this is a component where we are subscribing to a certain thing. So right, let's see how this works. Okay. So again, this is how the GraphQL, our GraphQL schema looks like. This here is not familiar with the GraphQL AWS Lambda. So the GraphQL AWS syntax is, I think you're going to hear in your class, you're going to go quite a bit about this. But in very short, this is just a very concise notation how you can define, how you can write down your GraphQL, how your GraphQL schema looks like. So it's basically, if you're familiar with typed languages, this could be like the equivalent of a type. Right. So this is how our example looks like. We have a message. We also have the concept of traveler, which is basically just the person who travels the world, and wherever this person is, the person has also a location. So let's look at it. So what we're looking at is basically this very Java account, Java application. So you can actually open on the code if you're interested. But what all it does is it checks where am I when I'm in the link currently. And yeah, so you see all the other persons who already opened this, and you can check if people from all over the world already around the world. And other person should be able to see that. Right, so yeah, so when somebody else says something, you should be able to see it via this website. So we have this phrase tab here, and whenever that person does something, this area so the formula in the code is also another way how we can test this. So you're probably familiar with the GraphQL editor. So this is basically an extension of the GraphQL editor that we call the GraphQL playground, which allows you to also use GraphQL subscriptions. So here, for example, we can run a GraphQL subscription. So absolutely. Right, so here, by inspection, you can see what's available. What I'm looking for query, and what I'm looking for is subscription. So I can look for travelers, messages, or locations. I'm interested in message only, and for the message, I'm interested in the text, and I include the text. So name, so I can subscribe to that, and whenever somebody does something to it, says message, there it is. So, yeah, you here, and you basically get all the messages that are available. So this is really helpful if you want to play around with the query and you have a subscription before you actually type in the app. So let's take a look how that actually looks like. So you can also take it out afterwards on this spot here in this repository. So as I starts with app.js, where we have our normal network interface and our subscriptions network subscription client. We combine them here into one network interface and then inject them here into our React context. And through this React context, we can then run subscriptions. So we do that, for example, here in this roadmap, where the roadmap can make the map and the setting and the layout. So we basically run this usability as soon as the component comes. And here, this is how our subscription looks like. So in this case, we're interested in the locations coming, and we want to protect them onto the map. So in this case, our only location we're interested in the left origin and the name of the product. Similar looks like for the set. So for the set, in the component command method, we're subscribing for the messages. Right. Does this give a roughly understanding of how GraphQL subscriptions bind into your React? also see the starting is how it looks like on the server side. So based on our proposal, this is how in theory subscription architecture looks like on the backend. So again, we use subscriptions for the website but also the server side to establish the connection. And then we have use the GraphQL subscriptions auto library, which basically implements a simple upstart mechanism, which you can back by, for example, a Redis subscriptions engine, where the server basically creates these balance, and then another server says, now we want to trigger a method that triggers the subscription. So this basically already brings us to the most important question about GraphQL subscription server, which is what does the server actually need to do? And this is basically where it's similar to your application. So the server needs to trigger subscription and needs to do that event as soon as something updates going into your business application. So, for example, in our case, for the message, for the chat app, as soon as somebody creates a new message, we want to get want to know about this message. So what the server needs to do is it has established a website connection between the clients and the server. And as soon as somebody else triggers a mutation, throughout this established website connection, it sends the subscription. So the server is responsible for hosting the communication protocol, in this case, might be WebSockets, and in this example, it might be the server side clients. And the server also needs to implement business logic. This is pretty tricky, since if you're talking about a Facebook scale GraphQL subscription implementation, it is fine for our small chat message app. We can pretty much get every message coming in. But if you, for example, implement that for new comments in a Facebook feed, and Justin Bieber posts something, and you want to get all the comments that are coming in, either like not 5 or 3, but either thousands, tens of thousands of comments. And if you have on a mobile device, the device might not be able to process all of these tens of thousands of comments, or maybe it's just a bandwidth issue. So the server kind of needs to deal with different parts of this process. So we're going to talk about this in a second. But first I want to give you a bit of an understanding of how this entire upsum mechanism would work. So if we go back to our initial architecture here, basically how does this system look like? As soon as something happens in the domain layer, there might be a new message was created, or somebody wrote a comment, or if you have a website and you want to be notified when the order comes in, these are events. And these events translate to the event present to the subscription, and the subscriptions are stateful hosted inside of connections between a client and the server. So these are basically 2 layers. And how we implement that a Graphcool looks roughly like this. That you have your users, and these users are connected to the WebSocket server via a WebSocket connection. And then you'll also have your traditional API server where users might send GraphQL applications and therefore trigger events. And here we have this middle layer that we call our subscription server. And this basically maps different kind of events to existing subscriptions. So if you think about this user, for example, he's maybe interested in the messages and in notification services. So in one connection has 2 live subscriptions. And here, this WebSocket server basically maps these two kind of subscriptions to different channels. In this case, the diagram doesn't really make sense, but you have several channels. So a channel might be for a message, for a location, and so on. And this is how the subscription server gets events triggered by the API server. And the subscription server then funnels them up into the existing subscription connections. So our subscription implementation is based on script in Scala and based on upper efforts, which help us to scale that quite efficiently. We have a subscription bucket, so this is one of these buckets per subscription channel. And we have these channels basically predefined of different kind of mutations. So we have a channel for when a message was created, when a message was updated, when a message was deleted, and so on. We ran into all sorts of challenges while implementing GraphQL subscriptions. Most importantly, we have now to manage a lot more infrastructure. So if you think about traditional GraphQL servers, HTTP-based, scaling them is quite easy, since all of them are stateless, and you can just, if you have more load, you can just spin up more servers. Since subscription servers are stateful, you have to, the entire scaling process gets a lot more difficult. Also, when we're talking about real-time subscriptions, they need to be really fast and efficient. So we run into all sorts of different problems around memory. Actually stated here twice. And, doing that is quite tricky. And I'd be curious if somebody is already implementing your own subscription server into which kind of problems you have to do. Right. We already talked briefly about the business logic of this, being that we need to basically have strategies when a lot of messages come in. Maybe the client is not able to get the messages right away, so should the server guarantee the delivery of these messages or not? And all of this business logic is very much on purpose not specified in the GraphQL subscriptions specification. So all of this highly depends on your use case, basically. So what Facebook, for example, does is when a lot of messages are coming in, Facebook prioritizes them and says, these are the messages of these are the comments of your friends, so you should see them, or you see other unimportant messages from a stranger. They also do a lot of aggregation about these, they have tons and tons of events, they aggregate them and send over different channels, they send aggregation, and then you also want to have custom responses for the subscription. So when you have user A and user B, maybe they shouldn't, even if they subscribe to the same kind of event, they maybe should get personalized messages through the subscriptions. So there are plenty of new challenges here you have to face the business way. Right. So this is really just a brief overview of the GraphQL subscriptions. I think all of you should be able to try out on the client side at home. Hopefully you're also curious to think about how this works in the backend. So there are plenty of resources you can write and you can move into. So I think this is the most important one. There is still the pull request currently open for the official RFC for GraphQL subscriptions. This one is also a super interesting issue about live queries. So basically the other part of the counterpart to GraphQL subscriptions. With live queries is what we already presented last year as GraphQL. There's also a bit of an older blog post, but it's really interesting what kind of challenges Facebook faced. How it's still facing with GraphQL, why they did GraphQL subscriptions, is just in order to deal with performance. And yeah, if you want to get your own scaling, there is a video tutorial how you can use GraphQL application. Right, as said, there will be the GraphQL Zero conference. And if you have any further questions, please talk to the community or the facilities after the event and come and talk about it. All right. Now I'm really happy to give the mic to Nick, who is going to tell us about his journey with implementing GraphQL in Go and the learnings in particular the RESTful library around subscriptions. So, yeah. If you have any questions about GraphQL subscriptions, talk to me this afternoon. Cool.
It's not a problem, I think this. No, what's that? This computer is. Are we still online? Are we still online? Yeah. Yeah, but it's just so I still try to figure out how to do it. Like the sound was like there's a lot of background noise. I would assume that you just still this speaker.
Yeah. We wait 2 minutes for people to come to the document.
So hi everyone. As Johannes already said, this is a more theoretical talk. So if you have any questions at any time, just raise your hand. I'll try to address them right away. So everybody can say more. So my name is Richard. I'm a full stack engineer, but I think a lot of people say that nowadays. So I would say my motto is never stop learning. So that's why I basically also jumped onto the GraphQL wagon and tried it and really liked it. That's why I introduced it at a company called SourceGraph, code intelligence. And previously we had some gRPC-based API layer, which was really big, I would say. So big in terms of all the code required to make that API work, and GraphQL is much more lightweight, and that's why I like it a lot. So it's a Go code base that we have, and I was looking around for a GraphQL server for Go, but unfortunately the one that existed I didn't like that much. It was kind of a JavaScript server translated to Go, and in my opinion, it didn't really fit to the Go, to things that you usually do in Go. So what I did is I wrote a new GraphQL server in Go. And for that, obviously, I had to read the spec quite in depth. And yeah, look into all those details. And so now that's the reason why I want to do this talk. But if I now talk about Go, then most of you will probably not have that much gain from a talk, because you use other languages. So what I want to do instead is to talk a bit about what I learned about GraphQL and its specification while doing so, and especially some things that I noticed. Disclaimer, this is not a rant. I like GraphQL, I respect the work that went into it, and I would recommend it to use it definitely. There might be good reasons why things are the way they are. It's just that I want to highlight some things that were a bit bumpy while implementing that GraphQL server, and to give you food for thought, to just see what things might be important when, for example, writing a specification about something new. And so the GraphQL specification is really good, I have to say. I've read some other specifications before that had kind of bugs around like undefined cases where you say the spec is ambiguous, or some really just syntactical weirdness in the specification. And I can really say the GraphQL specification is a high quality one. So if you're somewhere in doubt when using GraphQL, don't just look at the examples, you can actually look into the specification. You should be able to read it very well. Unfortunately, the spec itself is not machine readable. It needs testing for compliance. It's not trivial. You have to write your own test, you write them from the spec. I know Oleg is also very interested in that topic. We try to improve that. And I did my own kind of work around in my project. So that's something where I still hope that we will see improvement on having some actual set of tests that we can run against multiple GraphQL servers, including one. But now this talk will be about the question, is the GraphQL spec simple, or is it as simple as it could be? And why simple? It's because in the Go ecosystem, simplicity is one of the core values. There's a great talk by Rob Pike about simplicity, and he's in the end, when he wraps up the talk, I have to recommend you watching it, just Google it. He wraps it up with simplicity is hard to design, simplicity is complicated to build, but if you get it right, simplicity is easy to use, and that's what you want when you build tools for other developers. You want to make it that it's really easy to use, but it's difficult to end up there. So that's why maybe some parts of the GraphQL spec are not as simple as they could be, because there was some kind of evolution process until it ended up where it is. So let's dive into it. What do I mean by simplicity? A very nice, clever, and simple thing in the GraphQL specification are insignificant commas. Maybe you haven't noticed it yet, but I think a lot of you guys know the situation when you have a JSON document, some list in it, and you delete the last entry of that list, like a full line, and suddenly your JSON is invalid because you forgot to remove the comma of the previous line. It's annoying as hell. Some other languages have worked around that by saying, okay, you have an optional comma at the end, but GraphQL spec has a really, really simple and nice solution. They simply say commas are white space. They are treated like line breaks, like tabs, and so on. So the parser really skips all commas. All those notations that you see here are valid, and it's kind of up to convention which one you use in which case. So for example, for lists and multiple lines, you will probably prefer that one. That's what you often see in GraphQL queries and schemas. And for this, you will probably want that one because it's easier to read as a group, especially if the entries are bigger than just single letters. So that's really, really clever. On the other side, on the negative side, a simple example, not so simple, is in my opinion non-null. Why did they do that? Because it's an operator that reduces the set of possible values. You have the integer type, it's all integers plus null. And now you need an additional operator to say, no, I don't want null in there. And it's especially strange since in the ecosystem where GraphQL is, there's, for example, TypeScript and flow type even from Facebook itself. And they have a nullable operator, a question mark. So they say the integer type itself is only integers, and if you want to null, you add a question mark. In Rust, it's also similar, and then there are several other languages. But for some reason, in GraphQL, we decided to do it the other way around, which leads to this. Usually, you want this. I mean, most APIs are better to have less special cases. So you want an empty list or a list with actual content. But to do that, you actually have to write more in your schema. You have to add like those two exclamation marks saying, okay, no null elements and no null list. Because if you use this one, you can have null as a value, you can have the empty list, you can have null in the list and mixtures. And the problem is, as I've seen in the real world of my team, is that people usually default to this one and write the schema. And then you have those special cases in your API. So I'm wondering, why did they do that? Yeah, it's a simple example where I would say that's not ideal. And also while implementing the server, I noticed that I often had to wrap this around. So I actually unwrap the type inside of the non-null, then process it, and then make a check for if it's actually non-null or not. So in the implementation, I could actually see that this is somehow the one way around. Okay, next. A bit more complicated example now. I hope, could everyone follow up until now? I think that for the easy examples, now it gets a bit more advanced. And now I want to talk about orthogonal features. What are orthogonal features? Just go look at the table, look at the Lego. Those are orthogonal Lego pieces. Like, you would not use any other piece if you need. If I would need this piece here, I would not use that one. And you can say that for all those pieces. Like if you want to build something, every piece has its proper place. And if you don't have orthogonal features, then just imagine like 3 of those pieces mingled together into one mega piece that you may use to build what you want, but just imagine your Lego model built of those mega pieces. It doesn't look as beautiful as with those simple pieces, right? So now let's transfer that to programming languages. I'm comparing Go and Java, and for example, you want something that has methods. You want to call methods. In Go, you just take any type and give it a name. Suddenly, you can call methods on it. You can have an integer type, give it a name, call methods on it. In Java, that's a class. You want to have fields, something that's like a composite data structure. In Go, that's type of kind struct. In Java, again, that's a class. You want to pass something by reference to then modify the content and, as you know, just see it everywhere with a change of the content and not just a local value. That's a pointer. not as bad as in other languages. In Java, it's again a class. So if you want to pass an integer by reference in Java, you have to actually wrap it into a class because you don't get the concept on its own. Does that make sense? What feature or orthogonal features are that you can kind of combine them as you need them? Yeah. So now let's look at GraphQL types. I think you should all be able to see those three types here. It's a simple object type on top, an interface type in the middle, and a union type at the bottom. We have the type cat with the name and the cuteness factor, and the pet just may have a name. So those three types, what are their features? Those are the features. Let's look at the first feature that the type can have. It can have fields. That applies to the object, and have fields and applies to the interface. But the union cannot have fields. If you query the union, you always have to do a type, type assertion. I always forget the name of GraphQL calls it. But you have to basically say, okay, what type is this? Is this actually a cat? And the spec really says unions cannot have any type, any fields. You cannot query fields on union. So that's the no here. Next feature is the type virtual. The cat itself is an object type, so it's not virtual. The interface is virtual. You can have a cat in there, you don't know whatever. It's the interface. And the union, of course, is also virtual because it obviously says there's a cat or not. Third feature. Can you declare it on top of an existing schema? So you have a schema with a certain amount of types, and now you want to add something on top. So of course you can add a new object type, no problem. You just add it to your schema at the bottom or wherever. You can also add this union here because cat and dog, they know nothing about this animal type. You just add it somewhere and it works. But the interface, for some strange reason, needs to be declared up there, the implement statement. So you cannot have an interface without modifying the declaration of the types that you want to use in that interface. So that's a yes, no, yes. Now look at this nice pattern. Somewhere in each row and each column, you always have a no, which is a bit strange. Because when I implemented it, I eventually mapped all those three types to one internal type that has basically yes everywhere. And all those three types are internally transferred to that common type. And for example, an object has no type assertions because it's not a virtual type, and the union type is just an interface type that has no fields. So I would say this is not. Those are not proper orthogonal features here. And you could at least remove the union type, for example, and you would lose nothing here. You could still express all the schemas by your interfaces. So far, so good. So, yeah, and one more thing, the implements here might be able to solve that in some different ways, so you don't have to have that there, then you could put a yes here, and you would also have that situation. Again, I'm not saying this is bad. There are reasons why it is built this way, but I think it's important to realize those aspects of the language, just to maybe see when you later design some other system that such things are important for simplicity. So everyone on board still? And relax your brain a bit. You have the cuteness factor with a cat. So obviously you have a cat. And relaxed. Next. Orthogonal features 2. Fragments. We have a fragment on a cat. Again, the cuteness factor is in there. And we have a query here. This is a named fragment. I hope everyone can recognize this. It references the fragment above, and this is an inline fragment. And now, how do those two fragment types relate to each other? Again, you take and we have this time only two features that they provide. One feature is they provide a reusable field selection, meaning that you deduplicate your code. You don't have to write the same fields everywhere. And of course, you need a named fragment because only when you have a name on it, you can use it in multiple places. An inline fragment can only use the fields in one place, so that's a no. On the other hand, they that's also by assertion, but by condition, meaning what type is the actual thing that you're querying. And type condition you have on both. And actually, on the fragment, it's mandatory. You need to have the on head here. And here in the inline fragment, it's optional. Now you're wondering what happens if you remove this, then it's just the field. You can have directives on that. That's why the spec supports it. I was really surprised that was something that I only found out by applying actual tests from the JavaScript. So those two, again, are two different options for two different features, but they, again, overlap here. So I would say this, yes, is essentially not necessary. If you would have a node here, you would clearly have kind of one thing for one feature and another thing for another feature. But again, you don't overlap in this specification here about the features that the things provide. Okay, now, now you may say, okay, we have the on head here because we want to know the type. We want to look at the fragment and see, is this fragment correct? Does the type actually have a cuteness factor field? And if not, we say the fragment is invalid. Okay, that might be a reason to have an on head there. Okay. So this, that you say, you make it possible to look at the fragment on its own in type check. Unfortunately, that breaks as soon as you have variables. So we now say we have a unit on the cuteness factor as an argument. And I don't know how you measure cuteness, but I bet in the groups table, and that in the imperial system it would probably be a different unit than the metric. Recording stopped.
Just start again.
Sorry about that. There it is. Sorry about that. So now we have this unit. We have the cuteness factor. And as I now, as we already saw the on head specifies the type of the object that we're currently looking at, and you know if it has a cuteness factor or not. But what about the unit? What about this unit variable? Does it actually fit to the parameter that the cuteness factor has? And the only way to check that is to look at the query itself and to look at the context of where your fragment is used. So the type information here comes from here, goes through here into the fragment and there. Which is again two different ways on where your type information comes from. And again, that's something that you notice when implementing the GraphQL server. That's what I can tell you. Yeah, so I would say also not the end of the world like everything, but again, it's strange or a bit bumpy. And now just an example on one way to solve it would be to say, okay, we have one feature here, that's the type condition. I left out the ... because that's not a fragment anymore. It's actually the type condition as something we can write without any fragment involved. And then you have a fragment here, and the fragment has no type condition anymore. So all type information when looking at that fragment has to be inferred from the context where it's used here. Any questions around that? Yeah?
So what is the difference if I remove the double cross and if you have it? What is the difference in the implementation?
Because basically I assume the same behavior.
Yeah, sure. You have the same behavior, but the question is, are you actually expressing it in those simple Lego blocks, or do you have those more complicated things that you put together? Does it make sense to reason about the Lego blocks here? So of course it's possible, and I could put a lot of other characters here to add to it and still have the same behavior. But orthogonal features lead to simplicity. If you have a more complex thing like GraphQL, for example, a whole programming language like Golang, then that is even more important. So on the other side of the spectrum, for example, is C++, because you have all those different features and you have all those different ways how to end up at the same outcome. And so, like I said, in GraphQL, it's good the way it is, but I thought it was a good example to actually show those aspects of the specification to give you food for thought or what done. Yeah, thanks. That's it. And there's again the link to my server if you want to take a look.
We need 5 minutes questions and then 5 minutes break until the next talk.
Okay.
Here's the mic. Everyone has the mic.
Yeah.
So, there's this sort of path that you have to do for a workaround with Relay to re-expose the root query. You know what to do? Yeah. Is it totally possible then to just simply use the inline fragment to re-expose the root query?
I follow.
Well, what I mean is when you're using Relay,
Yeah, you always have this additional graph on top, right?
yeah,
Query and
with the
say
root
root.
queries. Yeah, so you use URL as a system vector.
How
But then you want to use, when you want to access a container from within a query that doesn't have like a URL or something like that. You have to re-expose the root query. Like say for instance, the GitHub's GraphQL that has a relay query which is just re-exposing the root query. Really, typically possible in Schema then to just use a fragment, an inline fragment on on query to re-expose it in that way.
What I can say about that is maybe to put that into the topic of the talk again, that the reason why you have to do it is again because somehow the simplicity got lost. Because somehow Relay started to assume that there's some top level thing and added some context there. I mean, at least in our implementation, we are not doing anything at that top level. It's just the root container with its things that it does. And yeah, we would not have that problem if the root container would not have its own query thing that it wants to do and you cannot stop it. So that's again, I would say, some simplicity or lack of simplicity or how it happens. Then you have to do some.
It depends on the relay itself.
Yeah, because in the GraphQL spec you don't have that. The GraphQL spec is simple, but Relay somehow added all of it is required. Yeah. Yeah. Relay 2 was also supposed to be able to be available pretty soon. Still waiting for it.
You talked about programmers use the, I don't know, I'm not really into GraphQL, but the other syntax instead of the one, with the mouse and stuff.
Yeah.
And also demonstrating that many features are not orthogonal. Yes, but how feasible do you see like some tooling like Optonaut or VisiCloud, which like formats your keys and your streamers in a way, that always looks like that convention.
Okay, how should the tool detect?
So like if you're having the not interface but fragment, if you have a fragment and you have a one case you name it and the other case you don't name it, and then people use those syntaxes all over the place. You see a transfer automated tools to convert the source code to a common.
You mentioned some canonical way.
Yes, canonical way.
Yeah, I mean, in the current shape of this, there are reasons to use inline fragment, there are reasons to use main fragment. The only case when you really can do automatic checking is in this case, where it really doesn't matter if there's a comma or not, so you can kind of add a convention on top of it with a tool, like for example the Go format tool in Go, lets all those format discussions go away. But in the other cases, already here, the tool doesn't know what you actually need there, right? So you cannot do any automatic.
Yeah, you would. Of course, you would have to establish some way in your company to say, okay, you're not using null. So, and then
of course, if you say no null at all, then you can check.
But concerning the fragments, could you explain why I would left the main one and why I would left the not main one? And one more.
Yeah, so the main one is mainly used that if you want to reuse it. If you have a query where multiple places you select for the same fields, and then you use the main.
And when would I not use the main one? I will use the
so, I mean, the name fragment has both yeses here. So in theory, you can simply eliminate it in that.
Yeah, that's what I'm talking about.
But that would look ugly in quite some cases where you really want to have the type condition there. And to then always jump around in your query to where the extra
I don't understand. Okay, I don't want to understand.
It's just a question of reusability, I would say.
Since
there are two yeses, you can eliminate this. But one more thing, you can actually, you're not saying those are interchangeable, they're actually remarkable. The spec allows you to declare directives only on one of the two. They are not interchangeable anymore. So that's one more thing the spec has.
Okay.
So just say
Can you put up the timeline or that's okay? So we take 5 minutes break.
5 minutes.
Then we have another talk.
How is it recorded? How is it talk recorded?
It's on YouTube.
You record just with this and
No,
screen recording?
it's a lot of stuff. So this goes to stream. This one is just a speaker, and speakers have screencast and mic on them.
Okay.
Those 3 streams. So this one and
Will be cut together.
yeah, they will be merged together in one, and this one is completely separate. The stream itself.
Okay, because I was expecting some camera up there filming them.
No, it's my first time. Like it's probably would be terrible, but
If we would have
No problem.
live stream from Zoom, we could have used this camera up there.
it's my first time. I try to stick to what I was told to do.
Yeah.
Because I myself have no idea what I'm doing. So it works. It works, but there's a problem.
Oh yeah, you just definitely stream, I've checked.
Oh, how is the audio?
Oh, I haven't checked out yet.
Yeah, there's a problem. Like the stream itself looks fine, but the audio is terrible. Like,
okay.
I'm not quite sure. Like test. yeah, you see, I have no idea. Like, no, the whole world listens to me and sees how stupid I am. Like, this audio, it's wonderful.
Don't worry, it was just
Yeah, not just
2 or 3 people from now.
it was nice talk. Quite interesting. Is definitely something. I also
No, it is not. They solve the same purpose almost. And then you run into those weird situations where you, for example, first use a union, but then at some point you realize, hey, you have some field you want to add, and suddenly you kind of change it.
just a second. Let me stop this for a moment.
Transform that into like a database ID. Yes. And then you have to manage that. But using, you have to basically apply something that I haven't done that. Yeah. This is in my client, I've actually transformed that from in the URL we'll take the ID and then URL ID. Yeah. Apollo had some serious problems with that, especially when connecting to.
All right. So I hope your grades are generated with a smooth transition from one task to another. So I'm really happy to have our next speakers. So they actually came quite a long way from the training. And so maybe you actually already use some cool safe code, so they are offered GraphQL whatever, which is a really nice visual way to look at your GraphQL schema. And also quite recently, you guys use all GraphQL paper. You probably heard more about these tools. So yeah, a long call to you guys. Hi everyone. I'm Roman. This is Roman. And I need to interrupt and you can know us as API Guru, and the rest of the connect it into the browser, to our website. And you can communicate it. And if you open GraphQL Meetup, you can see us here. And we are the most eastern door in Europe. Nobody, maybe somebody in Russia, if you will. And yeah, and to describe our working condition, which is like that. And we like obsessed with this. It's a rest on our work and our practice. It's actually a screenshot from our website. And today we will talk about API tooling. And it needs to be different from other jobs because usually people say why GraphQL is great for front-end engineers or how it creates troubles for back-end engineers. And today we'll talk about people who play tooling. And to show you a little bit few examples, like any introduction talking about GraphQL should contain around about REST API. Yes, requirement. And in RESTful, API usually consists of PGP generation, notification generation, and API console. Maybe using also Postman tools. And that's pretty much everything. And we look like one of the main problems which limiting tooling role bunch of questions like that, speaking about or asking about best practices. And if you backend engineers, you need to make a decision, a hard decision which of best practices you will support. But fulfilling after decision problem, because you need to support all of them, at least the most popular one. Like to describe why it's happened, it's because that was initially introduced as architectural style, not a form of specification. It's a lot of flexibility and a lot of experimentation, but it makes life harder for people to implement like that feeling. And really into this stuff. We learn like we do architecting for 2 years already, and we are responsible for this one. And if you move more, instead of spec, you will find bunch of books. Probably they will have special forward for books about Rust. And one interesting that 3 out of 4 books is describing RESTful IPS. People usually don't get to call their IPS. It's really hard or even impossible to implement new REST with open source. And first time we saw GraphQL and we started reading about it, we quickly found out this specification, and we were just happy because it's like a form of specification. It's like our dream comes true. We don't need to have a bunch of like try write every bunch of public testing. And when we were deeper, we found out even more features like that system. So what that system allows us, it's allow us to receive predictable responses and to understand which parameters is acceptable. Moreover, it's like it's pretty simple. There is an interface using types. And what's even more interesting, you can query from server itself. And so Kubernetes can, when you specify server, Kubernetes can just run special query and receive a response and use it. So we don't need to do like configuration or specify files. You can just run the special query. And we like these 2 features and wanted to do something with it. And during our period when we familiarize ourselves with GraphQL, we watch a bunch of videos and read a lot of blog posts. And what we usually solve there is JavaScript code or graphical or JSON, but now see GraphQL. So we thought like with GraphQL, so it should be some graphic presentation of GraphQL. And we actually did it. We call it GraphQL Meetup because GraphQL is like exploration. And I encourage you to try this. There is online demo. By the way, if somebody tried, okay, wait, it's really impressive. And if you didn't try it, you can go to our demo or you, I believe GraphCool have this feature integrated, so you can create a system and this works with the type. So, yeah, like most of you already see this. But just for the record, for people for YouTube, it's like a graph representation of the text system and it's highly interactable. You can click on the text, you can click on images, you can switch from type to type. And there is a left panel which synchronizes with the text itself. And in this left panel, you can see these details for currently selected type. And it's pretty similar to
when you create when you display a full graph or Star Wars like that, yeah, it's like Star Wars like that, it looks like that. And it's pretty big. There is a lot of boxes, there is a lot of arrows, roughly like a mess. It's probably unreadable from the distance. And if you look deeper, you will see interesting pattern that you can set. Probably you already know it's the right connection. So for every connection, there is a special kind of connection and address. So you multiply almost like number of times by 2. And that's why the graph is larger. But the cool part about the array is also have a specification. And this specification describes the mechanism how to detect array types. And this allows us to create simplified versions of that. So it's more manageable with single query. And yeah, and like my main point is specification methods. We can describe some interesting details about specification. But most important part I think this is specification. And it's already big achievement in my area. So after building this tool, we did not stop and create a few more. I used Roman variable, so we need to pass a module form. It's a column, new stop, and start talking about feature which is not yet official part of the API, it's still schema definition, but since we do know this one, so already defined and try to use this idea. So examples I believe no need to explain. So not people, so this idea describes our class, so name and listener, and this is first name, last name, and different order. So another nice feature of GraphQL is directives. You already from the start talked about speaker directives. This ability is defined by the spec itself, and they can be used only on private. But there are, we have possibility to define custom directives, and one thing you can use it on IDL. So you can use it on fields, you can use it on types, on colors, on fragments, as we just mentioned. So, yeah, so that's how we decided to leverage ADL and directives, and that's how GraphQL later formed. So what is GraphQL framework? Basically, it is mocking tool for the GraphQL center. So I will show you example. So we need to define our own directive is a name type, and it has type parameter type, which is type of fake data for that field. So we can see there is file name, there are a bunch of these types of fake data. We actually use them. We actually use type of JS for this software together to get generated fake data. So if we add a few more directives, we will have something like this. We are taking the first name is first name, and respectively last name is last name, and also we support locales, thermal locales, and another directive we define is examples to specify the values that should be used in the field. So if we feed the IDL into our individual computer, we will get two features like regular GraphQL server. We can play with it using graphics. So here is an example of client ability server, and here you can see a response. I'm not sure how localized it is, but it makes sense to do the same example. Yeah, so we can so one of these two that we use. So the night is great before the night. So what does it mean? It means like we don't have any GraphQL server, we want to create one before you
fill the shade and try something there. But if you already have a GraphQL server, this tool can be useful too. This can be useful for extension. So let's imagine this page in your contact engineer and you're working on some new tool. You need, let's say, new fields for the field. So you have to go to backend engineer and ask, okay, I need these fields. You have to implement them, and this takes time. How we can look at this GraphQL paper, so contact engineer can take these fields and work with them without the engineer code when it's ready. So from technical side, we have to write this simple API, and let's say an example. So this API says we are extending type while, and we add new field, which is this name type string, and we use warrant for the text as a fake data for this field. So how does this work? So you write regular while, is that the field as it is below field. This goes to GraphQL second function. This process treats this type field and sends it to GraphQL server. Server responds later, and then this field mix up take the data into this response, and it doesn't even feel the difference between like real data and fake data. So it's like real data. So what I want to emphasize here is that this external GraphQL server, it is not some static server, it's just a regular GraphQL server. For example, it can be GitHub public GraphQL server. Here we have sample command which you can run and to extend like GraphQL GitHub server. So we believe this tool is like pretty new and we are like looking for feedback, but we believe this tool can change somehow the way front-end engineers communicate with back-end engineers and for the way you implement your front-end without touching the So that's right. So it's already a tradition for us to present some new tools once we speak. At the basement reception, we present our new tool that is work in progress. So we just take a sneak peek that. So let's start from that. When we go to GraphQL server, we have this ask for what you need, get the GraphQL server. I need to illustrate this absolutely nice, unique example. Really, when you start working with real data, with real GraphQL server, you put into that. So as you can see, you don't control the shape. This is a lot of clutter in the response here. You have to deal with the clutter in your UI. So you are not controlling the shape. So we decided to tackle this problem, and here I'm really happy to show you what we can do like this. Again, it's work in progress. So we are really looking for feedback. So lay them up. Let's open GraphQL. Here we have the same So what we suggest is co-location of while transformation. And explain all the names is actually all that So it's like you bring Lodash into GraphQL files. Let's try to start running this first diagram. So let's write map and this method is writing. Let's say let's move on. I think I'm this. Okay, the next thing we can do step by step. Something doesn't work. Next, I want to get this one. can now. Then you can mind something like map from character to print this typing. Let's give it a proper name. When you see this person to put, you expect another error, but you expect another bit. So let's use another keyboard to do it. It's keyboard. Let's keyboard and final dash on the text. Let's use that value. Pretty awesome. It looks impressive in graphical, but the next question is how to use it in production. So this is an open question, we still don't know, but it has some thoughts and we are looking for feedback. So yeah, to understand how does it work, this is our the working name of this will GraphQL AWS surprise. But maybe we'll come up with some better name. Yeah, so we export one function, we explain where the best loadout directories. The first two things. First, the GraphQL without the directory, so you can run it against the server. And another is this function, install function, which actually does the transformation to this shape we require. So how it can be used? The first thing that comes to mind is conserving. We don't think it's a good idea because it will break the contract. All the tools, clients and tools will be broken because relay expects this contract with all the tools all the time expect this. So on this, especially you might look to prepare diagram. So we can put this transformation before our install or before similar to forward install. We can put it there because it will break the same. I believe we can put it somewhere between relay store and component. So component will get exact data of the exact shape, so you don't need to do this maths in component. So if there are some relay or there are Apollo client experts who can suggest how to do it and appreciate it. So again, as I said, it's quite interesting. So to sum up, all the tools we shown today they are impossible without nice features GraphQL gives us. For example, GraphQL Meetup is not possible without a system instruction. GraphQL paper is not possible without IDL and without directives. GraphQL is not possible without liability. So yeah, what we wanted to say is that GraphQL needs a lot of great features for API tooling. We believe we should that it will bring API tooling to the next level. It's topic of certification, next level of API tooling. Yeah, so let's make API tooling very good, guys. What down?
You left them off notice, yeah.
Okay.
I mean, you had it in the browser, right?
This?
So the thing is, with the GraphQL schema I could actually do type checking on the client side. Do I use this when using these directives? So our other very different. What happens if I make a typo in being accessed inside the directory for all people. Is it called the client side?
No, right now it's working totally, so we don't do it right now. We just have a concept project, but yeah, I don't think we should do it.
By the way, it's when you are wireless, so you don't have anything to run here. You just have the view. So what you do in this graphical gamma, you basically wire a server for introspection. You inject special view into the schema. So you get the same, exactly the same server. So if you make error, yeah, it's also highlighted. Yeah, and arrow is inside here. So right now we just do the concept and we have speed 7. So it's error. Once we see that, it should be.
So for everybody else who has maybe a bit more GraphQL, the RFC is a great place to kind of like, yeah, get your ideas on the road and let other people contribute to it as well. Right. So the last steps basically is the GraphQL Year ticket raffle. I would basically suggest that whoever tweeted about it, we do it afterwards, and we're gonna we can do two things. One, we find out right away, or we do it afterwards. What do you guys want? Right away. Okay.
Then I need a computer.
Oh,
Or I have one. What do you need? We need Twitter. Yep. Oh my god. Okay. Yep. We'll get this right. Right.
Speaking, I like it.
How can I? There you go.
My keyboard is routed, but I can very different layouts.
Not too many. Writings. Alright. I just need a randomizer. Filter random. Okay. Jesus Christ, is this paid? Hold on. So it's. Maybe you can just copy paste this list. There's some simple randomizers. Panorama. Hold on. So there they are. All right. Can we share this? Well,
Can you go to random.org
left, you did it modeling, right?
Yeah, of course. Of course, I'm a backend engineer, you know.
You have to try. You have to translate it. Right. So let's see if we calculate the first one.
Well, I need another beer. Let's see.
I just have the results here. So
that is 0. Yes.
So that is Will Clark. No Will Clark?
Maybe on the street.
That is very true. Right, so we're gonna reach out to Will Clark, and if that's not the case, then we afterwards pick up the that is Nutterpie from Twitter.
We're gonna reach out to each of them and see why Twitter is early and see them at Yeah, so that was it. This was the third episode of GraphQL Meetup anyway. I guess we already have a location now for this fantastic. So Andrea we gave her a talk at the first GraphQL Meetup. No, you called here. So we already have a location for the next GraphQL Meetup. We're shortly going to announce the exact date. And yeah, please stick around for a couple of more minutes to chat about GraphQL. If you have any questions, now you're a great time to talk
This is a funny graphic.
So, just a second. Let me stop the stream.